Hi, friends. Welcome to 360DigiTMG podcast. As you have already witnessed, we are trying to unearth a lot of things with respect to the current trends in AI and machine learning. And that's exactly what we are calling this podcast is. All things in AI and machine learning. Today, we are going to continue in dwelling the world of vector databases. And today we have Mr. Aditya as our guest. He is a pioneer in applying vector databases across various AI-driven applications that he is currently working on. Aditya, very happy that you have joined us today. Welcome to the show.
Yes, thank you so much, Sharif, for having me. We all know that everybody wants to be involved in generative AI nowadays, but most people don't understand the backend processes that are involved in creating such an application. And this is where vector databases come into the picture. So it's a pleasure that I have the opportunity to discuss the complexities and advancements in vector databases in today's world.
Thank you. Thank you so much that you share the same enthusiasm. So let me jump into the show, the discussion, I should say. Vector databases are becoming very, very crucial in handling the complex data that basically we are dealing with today. Now, let's start with the discussion. Can you try and explain the underlying technology that sets vector databases apart from the traditional database systems that we have been using all these years, like SQL, NoSQL, whether it is NewSQL databases for that matter? How vector databases are different from these traditional systems?
Yeah, of course. So we have to focus on the first word here, vector, right? So at the core level, vector databases will store the data as vectors, right? And vectors is what? An array of numbers that is going to represent data points in a multi-dimensional space, right? So this is fundamentally different from traditional databases like SQL, where we are using tabular data, where we are using key value pairs, where we are using a defined standard template that is going to be applied across the board. If you take SQL, for example, we all know that SQL is all going to be schemas, whatever schemas you have, whatever tables you have, right? When it comes to vector databases, the power of the database lies in its application of mathematical models and algorithms, right? We have such an algorithm, which is our approximate nearest neighbor or ANN search algorithm, which allows for incredibly fast retrieval of similar items from a very large data set.
That's fascinating, isn't it?
Yes.
So I could resist catching on this particular term, the ANN, which we all are familiar with, right? We call ANN, we are used to artificial neural network concept to be called in short as ANN. But could you elaborate in your own terms on how this approximate nearest neighbor, so-called ANN, in perspective to the databases terminologies, work and then how they are impacting the performance of databases?
Yes, definitely. So ANN algorithm, or as we call it, approximate nearest neighbor algorithms, they're designed for efficiently searching through high dimensional spaces to find the nearest neighbors of the query vector. So instead of brute forcing your way through the entire database, trying to find each and every vector, right, searching through each and every vector, you can imagine the computational requirements that would be in such a system. ANN is using tree structures or hashing techniques that partition the space and reduce the search area, right? So this kind of approach will allow us for real-time query responses, even if you're dealing with big data sets, right? And this is a game changer for applications where you require live processing, not batch processing. So if you want instant recommendations or decisions, ANN algorithms is the way to go forward.
Perfect, perfect. So speed and efficiency, these are the clear advantages of using vector databases today, especially with large data sets. Do you want to shed some light on how vector databases are also playing crucial role in integrating with machine learning models, especially if you talk about the world of machine learning is continuously evolving, right? So, what do you have to say in that area?
Sure, definitely. Again, we'll take an example here of SQL versus vector databases, right? So we all know SQL. It is a very traditional way of dealing with databases. We also know that SQL has been the same way for decades now, right? So SQL and similar databases, they do not have the capability of dealing with the kind of data requirements that we are having in today's day and age, right? The environments are more dynamic in nature. We do not have static websites. We do not have static users, right? It is all extremely dynamic. So this is where vector database excel. They're not just static repositories. They can ingest updates from live data streams and they can immediately make that data searchable. There is no lag in that. So this is extremely critical when we are trying to integrate machine learning models, where we are again dealing with live processing of the data. Because you will be able to dramatically improve the accuracy and the relevance of the outputs. Right? The faster you give the output to the end user, the faster they can continue with their task. Right? On top of all of this, vector database also support embedding of machine learning models directly into the database. Right? This is something that was unheard of. Embedding of machine learning models into the database. Right? So this allows for sophisticated query capabilities and analytics directly on the data.
Perfect, perfect. Very well crafted. I think a lot of our audience would probably appreciate the advantages that vector databases have to offer. Now, with these advanced capabilities, can you also talk about some of the cutting edge use cases, probably that you have been using practically in various projects? How vector databases are actually contributing in this area?
Sure, definitely. So vector databases are revolutionizing various different sectors, right? For example, if we look into healthcare, vector database allows us for advanced biomedical research, such as genomic sequence analysis. If you're trying to analyze DNA of anything, humans, proteins, amino acids, whatever it is a lot of data and it is extremely complex data that is constantly evolving. So you cannot use SQL databases here. You will need something that is extremely dynamic, right? So here again, in biomedical research, if we are looking at genomic sequence analysis, we can use vector databases to identify genetic markers and similarities, right? Then another area where this excels is finance, right? Now, your money is online. You're no longer carrying cash, right? At least not as much as we did back in the day, right? So we are using UPI, we are using credit cards, we are making payments online, right? So this also increases the risk of fraud. So using vector databases, we can deal with real-time fraud data and we can identify whether the transaction being done is fraud. We don't have to wait for a few days for that to happen, right? Then we all have heard about Tesla, right? Autonomous cars, self-driving cars. This is where vector databases will be critical because you need to make split-second decisions. You cannot wait for the query to be sent back to the database to find the right response, send it back to the car. That is too long. That's where accidents happen. So we need vector databases to manage and query spatial data to make instantaneous navigation decisions.
I'm not sure about others, but personally, I am more interested in fraud analytics being implemented right now. Rather than autonomous vehicles, I'm more concerned about my financial transactions.
Yes, definitely. We should be more concerned about that.
Correct. Okay. All right. So, thank you, Aditya, for your insights and right, have been incredibly enlightening. The use cases, examples, and all that. Right, you have very well um, put forward your thoughts in right, our audience perspectives also. Right, could be changing with respect to vector databases and its usage now. Thank you for joining us today and sharing your expertise.
Yeah, thank you. My pleasure, Sharat. So thank you for the opportunity to discuss a little bit about vector databases with everyone involved.
Yeah. Thank you so much, and thank you all our listeners, and tune in for more such interesting discussions. Stay in touch. Thank you so much.